All right, in this video, we're going to take a look at the different ways that your specific immunity can actually work. So we think of it more of like talking about our divisions of labor, if you will. So if you're looking at your specific immunity, and you're looking at their responses, there's really two major categories. You're going to use antibodies, or you're going to use cells. If you're dealing with cell-mediated immunity, the cell that you're going to use is your T cell. So kind of separate them out by what cells you're using. If you're using antibody-mediated, this is when the B cells are involved. So let's follow that trail first. So with antibody-mediated immunity, you're going to be initiated by a free antigen. So it basically means you have some kind of foreign invader floating around. It could be on the cell itself, or it just could be a protein. But what happens is you have your B cell that has an antibody on the surface. It's actually an IgD antibody. And so this free antigen will bind up to it, and it will trigger a reaction. So this cell is going to divide. And when it divides, you're going to create plasma cells, which are essentially these factories making a ton and ton of antibodies and releasing these attackers out into the internal fluids so that they can find that particular shape in that pathogen. Because remember, with specific immunity, you're talking about a lock and key setup. So the ends of these antibodies are going to have the physical shape that locks up to that specific antigen. So our B cells are going to make these plasma cells that are going to be factories for cranking out a bunch of antibodies to that specific antigen. They will also make memory cells. Now these memory B cells aren't going to be used in this initial attack. They're not going to go hunting, they're not going to make antibodies. What they're going to do is they're going to sit around and be ready for if you do run across that antigen again. So if you do find that antigen in the future, you can just turn the factory on and you're ready to go. You don't have to make the factories. So it'll save you some time and allow you to fight it off right away before they have time to duplicate and kind of overrun your system. Now, if you look at your cell-mediated, this is going to fall into two ways that you can initiate it. So if we're looking at ways that you can initiate it by an antigen-presenting cell, or you can initiate it by an infected cell. If it's an antigen-presenting cell, this means you have something in your non-specific immunity or B cell that ran across it first, and they're going to show it off to your T cells. So in this case, you have a healthy cell, and he's done his job correctly, so he's all happy here. And he's going to show off the antigen that he found. So let's say it's a macrophage. That macrophage ran across a foreign invader, they engulfed it, they digested it using the lysosome, kind of think of it like their stomach, so they have digestive enzymes in there. And then they're going to take a little piece of that foreign entity and they're going to show it off. And specifically, they're going to show it off on its little protein on the surface called an MHC class II. It's a major histocompatibility complex. So that's what the MHC stands for. So a class II is going to show this off to specifically a helper T. We can also call that a CD4 cell. So CD4 are helper T cell. The reason why you're showing a helper is because you don't want to kill it. So we're not going to show it off to a killer cell. We're going to show it off to a helper cell on a class II. So the trick that I use at using a class II is that you're calling for help and you're the messenger. So don't kill me. So peace, don't kill me. So class II, showing it to a helper. What'll happen is they'll talk to each other. They're going to do some what we call co-stimulation. Like, are you sure you're not sick? Like, you just found this? Yep, I'm sure I just found it. And then these cells are going to then divide as well. Just like what we saw with the B cells, we'll make a memory cell for future. And then we'll make an active helper T. So that active helper T is going to then release chemical messengers called cytokines. And these are basically the call for help message. So this is the signal to the rest of your immune system. So they'll call in your nonspecific cells like phagocytes, or they'll call in other specific cells like the ones we're going to get ready to talk over here, those attackers that can actually kill things. They'll call over some B cells. So this is the signal to say, hey, come here. We had something found that is foreign. We need to come to this area to then fight it off. So again, not killing this cell, it's the messenger, but we're going to definitely call other cells into the area that can kill things and find things. If you have an infected cell, so let's say this is a body cell that has a virus on the inside, so he's going to look sad. You still need to show off that, like, oh man, I'm making a virus. We probably should get some help over here and also kill me before I make more of it. So we're going to show off that little antigen on its surface, but we're going to use a different MHC here. So this is going to be an MHC class 1. So with an MHC class 1, you're saying, yep, I'm sick. Go ahead and kill me. And so they're going to talk to a CD8, which is also known as a cytotoxic T cell. And we'll do the same thing. We'll show off that antigen to the specific cell, so they actually lock up. And if I would have drawn this right, they would be like right next to each other, but I hope you're getting the idea. So we're going to show that antigen off to this one. They're going to do that co-stimulation. They're going to talk back and forth, like, are you sure you're sick? I don't want to kill you if you're not actually sick. Yeah, I made viruses. I'm done. So then we can actually release some toxins this way that will kill it off. So we're going to use a major histocompatibility complex type 1, show off the antigen, co-stimulate, communicate back and forth, and then we're going to do, similar to what the other ones do, some division. So we'll have an active cytotoxic T, we'll have a memory cytotoxic T, of course, because that's a theme here. So we'll have another memory cell. And since we're making killers, we probably should make something that can like rein them in. Say like, yeah, okay, you've done your job. You're all set. You can go away now. So we're also going to make suppressor T cells. And so a suppressor T's job is to kind of rein back an immune response once it's already done. Now with the active cytotoxic T cell here, our job is to kill off this guy. We can do that 3 different ways. So there's going to be 3 toxins that it's going to secrete. Granzymes, perforins, and those 2 should look familiar because those actually are the same type of toxins that you're going to release from a natural killer cell that we use in our nonspecific defense. But since these are called cytotoxic cells, they're actually going to have an extra toxin called lymphotoxin. So those are the 3 toxins that we're going to release right onto that infected cell. And so this is basically your setup for your specific defense. And hopefully that kind of helps make sense once you see it all laid out together. And be very thankful for all of these memories so you don't get sick with the same thing again.